discussed about the data warehousing architecture.
Yeah.
In that architecture, we discussed yesterday what kind of approaches architecture are there, and what kind of reports you can build out of that. We discussed.
Yeah.
Right now, today, what we'll see today, right? We'll see what is the data warehousing. We'll see what is the data warehousing, and data warehousing, what we'll have in the data warehousing. You see, this is what is the data warehousing architecture, what we discussed yesterday. And out of this, we have a OLAP reporting and OLTP reportings. We saw two types of reportings, and top-down approach, bottom-up approach. We saw. Now, see, we will be using this data warehousing and connect the reporting out of that and do the reporting out of that. So for that, generally, what is the data warehousing? We'll have to see. See, as we discussed yesterday, data warehousing is what? It's a large database. It means what? Data warehousing is nothing but a database only. So database having schemas. Schema having tables. Table having columns. Each column you have a nature of column called data types. Either a column or a number column like that. Okay. Now database is nothing but a storage area, right? Now we need to see about the schema. What is a schema basically? Schema is collection of tables. Collection of tables or a group of tables. Collection of tables or a group of tables. And when you talk about the data warehousing point of view, database tables. What kind of tables are available in data warehousing? Is dimension table and fact table. Dimension table and fact table. So what is a dimension table? How it looks like? I'll give you examples also. What is a dimension table? Is it contains descriptive. It contains descriptive information related to the business. Dimension table contains descriptive information related to the business, and it is having keys plus detailed information. Okay, keys plus description information. Similarly, what is a fact table? Fact table keeps entire transaction information. Entire transaction. Each and every transaction information will be stored into the fact table, and it is having just a second. Entire transaction information will be stored. It will store entire transaction. It will keeps. It contains entire transaction information, and it is having keys plus measure information. Keys plus measure information. Keys plus measure information. Now let's see how the dimension table looks like. This is the one. Just giving you some examples, like if you take customer dimension, you will have a customer code. Customer code is dimension, and you will have customer name, type, address, phone number, okay, look, age, gender, blah blah blah, little information. This is what is a primary key, okay, and then you will have a branch dimension. Branch dimension will have branch code as a primary key, and then branch name, branch type, branch phone number, fax, so and so. And if we take date dimension, day key, quarter, month, week, day. So now product dimension, product category, type, so and so. So we'll have all primary keys. Each and every table, we got a primary key. We got a primary key. So now what is the primary key? You know that, right? Primary key means any table, if you specify the primary key, it does not allow duplicates or null values. It is a combination of this combination of unique key and null. So what it does not allow duplicates. Unique key does not allow duplicates, and not allow null values. Okay, like that. So that is basically primary dimension table you have. Now the fact table looks like this. Customer code, branch code, date key, product code, all the key values, and then you will have measure values. So and so. Okay, this is what is keys. What keys is a reference keys. Reference keys are foreign keys. You can also call it as a dimension keys. And this one is all measures. These are facts. These are facts. So now data warehousing tables, dimension tables looks like this, fact tables looks like this. Dimension table is having key and descriptive information. Fact table is got keys and measure information. So now what is the schema? Schema now means what is? It's a collection of dimension tables and fact tables. We said collection of tables or group of tables, right? Now what kind of tables? Collection of dimension table. Collection of dimension tables and fact table is called as a schema now. Clear?
Yeah.
This is what schema means. You'll have that. Now type of schemas. We are saying collection or group. That based upon the nature of the group, what kind of group we are following, it's called as a, you know, that already star schema, snowflake schema, galaxy schema. That we're gonna see now. So types of schemas. This framework, while doing the modeling side also, we need this. We will gonna do the practically there. The schema, about the schema.
Okay.
I just want to, you know.
Is this a key means? Do we refer that key number to access the table or?
Yes.
Okay.
It's a detailed information. Generally, against a customer, against a branch, against a date, against a product, ETL people will load the transaction information into the transaction table. ETL people end up there load the data into the tables and columns. No, what tables, what columns, that data, dimension table and fact tables. They load dimension table information based upon the dimension table reference only. They will load the data into the fact table. That's why all the dimension keys are there in fact table. It's customer wise, specific customer, specific branch wise, date wise, product wise, the transaction information will be stored into the fact table. Okay, now types of schemas. Let's start with the start schema. There are three types of schemas. How the start schema looks like this. Centrally you have fact table and surrounding by dimension tables. Centrally fact table is called as essential fact table. For the results fact table, we have customer code. Blah blah blah. Okay. So out of this you will have a here. Let's assume this is a customer dimension. You will have a customer code. And then you will have a branch dimension. You will have a branch code. You will have a link like this. Customer code to customer code, product code to product code, date key to date key, like this. So now you see now centrally fact table surrounding by the dimension tables.
Yeah.
This is the measures. Measures are facts. This is, as I told you, dimension keys or foreign keys or reference keys. These are as a primary key. Primary key will join to the foreign key in the fact table. Okay, like this. So now, what is the star schema is centrally located fact table surrounding by the dimension tables. Centrally located fact table and surrounding by dimension tables, called as a star schema. You have center fact table surrounding by dimension table, and dimension table having direct communication with fact table.
Yeah.
Okay.
Yeah.
Now snowflake schema. These things we'll see practically how the framework manager level is joining. You know that schemas will be there database level also. If you want, if you are not using all the tables for reporting. If you want to use only few tables, and if you want to prepare your own relationships, you can do it at model level.
Okay.
So that time these things will come into the picture. That's what I'm trying to explain you how that looks like. You might have known already. That is the reason I'm just running through quickly. Okay.
Okay.
It looks like star schema. It means what is star schema? It looks like star schema. Star schema means we just saw now.
Yeah.
Like center located fact surrounded by dim tables.
Yeah.
Okay. Looks like star schema means central located fact table surrounding by the dimension table and extension. Extension of the dimension tables. So means dimension table having parent child relationship. Dimension table having parent child relationship will be there. You see how it looks like. You have customer dimension. There is a customer gender, and here product. You will have extensions like this. Customer dimension to the gender dimension. Customer, I'm just giving you, it's not like 100% it will be like this. Like boss is product, these all is extension for product. Like this is gender. So gender information is not available here. So what will happen? You will have extension relationship like that. And this is like a forecast dimension. This is the category dimension. This is the product type dimension, like that. So product is main, then it has to, you got a communication to product to the type, product type dimension, product to the category, product category to the forecast, like that. So extensions relationship is like that. Parent child relationship, dimension table having a parent child relationship. These are product is dimension is a parent, and then child is what? Category, type, and forecast. Customer is the dimension is a parent dimension. What is a child for is gender dimension. Like that you will have extension relationships. Snowflake schema means. Clear?
Yeah, but all that will be under primary key only, right? Again, that
Yes, it will be like common column. In that level, yes, it's the keys. Common
okay.
column keys. Based upon the common column only, it will be available.
Okay.
That level. Okay. So some of them, they don't maintain the keys also, they simply load the data. It's like if it is like really, should not maintain the duplicate, then we will maintain that keys. Some just leave it as it is. Now Galaxy are integrated. In our case, right, whichever is not having direct communication with the fact table, this is how that communication will be. Now you see Galaxy are integrated. It means it's a combination of star and snowflake schema, and it is having multiple fact tables, multiple dimension tables. So it is having multiple fact tables and multiple dimension tables. Okay, how that looks, let's see. You see, we have like this. This is one star schema, correct? This is other one. And then if we have like this, I have extension like this. So this is a, what is this? This is a snowflake. If we take this star, if we take this, there is also star. If we have extension here, there's also type snowflake. Okay. Galaxy will be like mixed.
The one dimension table may have references to multiple fact tables, right?
Yes. Lot of compound dimensions come back. Okay, now if we see difference between star schema and snowflake schema. So basically star, I'll tell you, we have already that. It's difficult to write. Star schema means that the less number of joints are available. Star schema. Less number of joints are available. More numbers of joints in snowflake schema. That's the reason performance will be good and the errors will be slow. And denormalized tables are available in star schema. Normalized tables are available in snowflake schema. And then OLAP reporting, most of the cases we use this. OLTP reporting, most of the cases we use this. And you see star schema, dimension table having direct relationship with the fact table, whereas snowflake schema, dimension table having extension relationship. It means parent-child relation. Dimensions having parent-child dimension table. Parent-child relationship. Parent-child relationship will be there for dimension table. So there is the just differences we used to say. Clear that difference between star and snowflake schema. So compared to that, star will be performance faster. So if you compare to snow, even slow because that it got different more and more relationships. Single dimension character with multiple factables and all. Okay, so these are the things is called as types of schema. Based upon the connectivity between a tables, we call it as a different type of schemas. Star, if we have direct communication, star. If dimension have an extension relationship, which is called snowflake. Multiple factable and multiple dimensions we got linked, means all. We call it as a galaxy. Okay. Hello, can you hear me? No. Hello. Trinath, can you hear me? Hello. Hello.
Hi.
Yeah, Trinath, there is some issue I think from your side. It says organizers having technical difficulties.
Yeah, something happened actually.
So, like that, we'll have to see types of dimension table. No, now based upon the schema behavior, like based upon the connectivity, we call it as a different kind types of schemas, right? Similarly, dimension table behavior, we call it as a different kind of dimensions. Okay, so let's take types of dimension table. Based upon the dimension table behavior, either schema or the ETL side or reporting side, or how based upon by seeing the data, getting it back that connection. Types of dimension tables. Confound dimension, zero dimension, computing zero dimension, role playing dimension, degenerated dimension, SCD. Slowly changing dimension, SCD. We got like type 1, 2, 3 like that. Maybe some other also. For most of the cases we use 3. Now, what is a confound dimension? What is a confound dimension? Is a single dimension connecting with multiple fact tables. What we do is, and as per the Cognos point of view, we access the data marts and pull the tables and make relationships our own according to the business requirements, and then do the reporting out of that. While bringing the tables through the data source connection, which is administrator will give, then the dimension between the dimension tables, it have like connectivity. Single dimension will link with the multiple fact tables. The single dimension connecting or joining with multiple fact tables. So where this will happen? Where this will happen is, we just saw the schema called Galaxy, right?
Yeah.
Like this and this. Any dimension, that could be date or product, whatever it is. It could be date, product. Let's assume this is a sales fact table. Let's say this is orders fact table. Right? So this dimension you linked with these two is called as a confound dimension. This dimension table is called confound dimension. This dimension is called what? Confound dimension. Okay, that is called as a confound dimension. Single dimension connecting with the multiple fact tables. We'll see practically also this where it will happen. Generally, I just show you the Galaxy schema. This will happen. Multiple means not even a 2. It could be more than 2, right? More than 1. It's nothing but multiple. Here, what we saw the Galaxy, Galaxy. This dimension. If we see this dimension, let's assume this is the dimension. This dimension is linked this table as well as this table, right? It can also link to this table, third one also. It's not like that it will be link only one. It can join, let's say this is the sales fact table. This is the finance fact table. So this is the order structure. Okay, so this dimension is what happened to this dimension. This is the one dimension. This is one dimension. It's linked to what? Sales fact table, finance fact table. It can also link. That's what I'm trying to see. It can also link to this fact table. Okay, multiple means like that. We just discussed one example. So it's called as a confound dimension. Now, junk dimension. Junk dimension. What is the junk dimension? Is randomly or rarely use a bin called junk dimension, and it is having low cardinality. Flag values. Low cardinality flag values means like indicator kind of values. Whatever the dimension, it has got low cardinality flag values. Example, gender dimension is there. What will be there? You have male and female, only 2 values. Indicator dimension will be there, active or inactive. So like yes or no, true or false, like that. Male, female, yes or no, true or false, active, inactive. Indicator kind of thing. That's called as a flag values. the dimension will use very randomly. Means it's not, you don't use that for reporting or for this, analysis point of view also. Very rare cases we use it. It's called as a randomly or rarely used dimension. Another thing is the dimension only got only lowest values like this indicative. Let's take gender dimension. If you see Galaxy snowflake schema, you have gender dimension. Generally, most of the cases analysis will be done by customer wise, what is the revenue, profit, margin. If you want to go lowest level of customer, male and female, what is the male wise profit, female wise profit, like that. If you take a product point of view, or a branch, active branch, inactive branches, or something like that, it means lowest level.
Yeah.
So lowest is like indicator kind of thing. So that's what it is. Call it as a junk dimension. Example, you can say gender or indicator dimension, whatever it is. Okay, clear, right? Junk dimension means that is what is. Wherever you have, very rarely we use that too. It should have only two values. Now, role playing dimension. Not getting bored, right?
No, these are new only, so I'm just following.
Okay, Vrishabh, because on a work day-to-day work, you'll not use much on this. As you, it may help you to clearing your interview. The interview point of view, what was there in the background? They'll just ask all these things. As if you are trying to look for a new job for Cognos, right? All these tables and information will be using for the reporting. No, they'll ask like, what kind of dimensions you have. Do you know data warehousing point of what is the dimension, types of dimension table, like confound dimension, zinc dimension. It will like namings if you keep in mind, and that schemas you might know from long, but don't make dimension. You just not brush up. That's why I'm just generally I used to take 2-3 sessions, but I'm just winding up with roughly with the speed, so that more also. Role playing dimension is generally that as you also database person, data warehousing people who maintain that database is DBAs. What DBA will does is he will create one relative date or time dimension, relative date dimension or relative time dimension, right? He will maintain dimension, and which is having 1900 to 2100 fast and feature. Fast and feature, the data will be there like that. They will maintain the date dimension like 1900 to 2100. Data will be there till that much, the date dimension. Okay, data warehousing date dimension generally, right? So this date dimension will be used for all the reporting purpose. Means let's assume that is there into the warehouse. Then whoever want to do the sales wise analysis and sales reporting, they also need this relative time dimension. Order reporting also, this date dimension is required. Without date, there is no analysis, right? Without date dimension, what was, what is, what will, you can't check. We'll have till the night data only. If you want to, like a future budgets, all those things you can't, analyze if you don't have a date and the date doesn't have a history. Means past or future. So that's the reason. And data warehousing, the data is important for any reporting, sales reporting, order reporting, finance reporting, HR reporting, all kind of data mart people, all kind of reporting people, they need a date. Date is mandatory. So what I'm trying to explain you here, role playing dimension is a single dimension reused or recycled with multi-purpose. Multiple business purpose. Call it as a role playing dimension.
Basically, in our company, right, there are some database with different titles each column. We just access them based on SQL queries.
Yes.
At the names, actually, we didn't really segregate the way you have been explaining now. So this aspect is new for me. And other point is this kind of, you mentioned, right, variable, character, integer kind of definition that we give for each column. So here also, do we give such kind of characteristic to the each we define, right?
Yes,
Okay.
we will. Means the ETL people while loading the data, they will creating the table system, they will specify, they will define according to the data will be loaded. But when we pull into the reporting side, when we pulling into the reporting side, that time also we will take care. Is it properly? Let's say customer name column is there. Customer name column properly, that is character. It is identifying as a character or it is a number. Let's say amount column, a customer code column. It is properly identifying as a integer column or it is identifying as a measure column. See, measure means there is a meaning will different. When you talk about a measure, yes, we will take care of that. Here I will explain you. After these things, I will going to explain you that. If you see this one, what we do is before making a relationship, I will make sure this. This is the customer dimension. This is the sales fact table. If you are trying to join between these two, customer code to customer code, both should be integer columns only. Cognos also should, our reporting tool also should identify as a integer columns. Sometimes if ETL people or database people, if they don't determine the user's property, that if they don't determine, what will happen, right? One table it became a integer, other table it became a fact, nothing but a decimal value. So what is the decimal nature is here is in a reporting side, it will do on a sum. It became a total. In a database point of view, your column is called a decimal. When it comes to the reporting side, when it comes to the tool, it understands as a total column. That column became a total here. Let's say one side is a customer code is there, 101 Trinath, 102 Guru, 103 Rama, 104 Paluri. So this should be, this side also 101, 102, 103 should be independent. What will happen? One side will be integer, that's why it is independent, 101, 102, 103. If other side also is integer, it will be there like that. But in other side, it became a fact, nothing but a measure. It is identifying as a measure. Cognos is considering as a measure, it will be proper. What it will do is, instead of 101, 102, 103, it became a 306 because it do the total. That is the reason we will make sure, making relationships, we will make sure each and every field that will come in the next. I mean, in while creating that model, I'll explain you that also. Each and every best practice. Generally, they have to give us a data dictionaries, like what is the table name, what is the column name, what is the length of the column, what is the data type of the column, everything they have to give. If they don't give also, there is some best practices or best tips are there to find out your own without any data dictionaries. That way also I'll teach. So that any project, if some people they can provide, they'll say you can go ahead and check and give roughly. So that case it will help you. This like how you can do that, we'll see. Okay. Right? Any doubts or any other doubts?
These only.
Okay. So this is now, let's say this is the sales fact table. It's a fact, I would say, like this is like sales data not reporting, sales reporting. I will say like sales reporting, finance reporting, HR reporting, order reporting, like that. So for all the things you need data is needed for all the reporting. Sales reporting people also needed, finance report people also needed, HR order report people also needed, HR people also needed. So your date dimension is role-playing dimension. This date will be used for multi-purpose. Here we are not talking about a join, we are not talking about a linking, but this is linking. Here you may get a confusion. This is what is join fact table or link, but we are talking about here usage. Usage multiple business. Multiple business area here. Okay, so that is usage. That is the linking. Nothing but within a one schema, a single dimension joining with multiple fact tables. This is we are just saying like sales reporting purpose also date will be used. Finance report purpose also date will be used like that.
Okay.
Similarly, people. Sorry. You asked me something?
No. Like basically the date dimension is something. Yeah, date DM is different, right? DM you are mentioning. Yeah.
No, DM means like date dimension. That is.
Okay.
Dim like dimension. I'm just mentioning a short name.
Yeah, no problem. Yeah.
Date dimension. There's a gap. Okay, right. That's all. So like that. Now, okay. So you got right what we discussed, and then there is a two other more dimensions are there. So let's wind up what are the things we discussed today, and then we'll continue that tomorrow. You see what we discussed today is generally ETL people will load the data into the data warehousing. ETL people will load the data into the data warehousing. How they will load the data, what all the information will be available while accessing, what we will get the terminology. That's what I'm trying to explain you. You see, data warehousing got a nothing but large database. It got a schema got tables, tables having columns, each column data types. Now, coming to the schema means nothing but a collection of tables. Collection of tables or group of tables, what we said. But data warehousing point of view, entire generally table means table is table only. There is also one part of database. Now, data warehousing tables means entire data ETL people will be loaded into the two tables only. One is the dimension table, other one is a fact table. One is a dimension table, other one is a fact table only. How dimension table looks like? You'll have a keys and a descriptive information. You'll have keys plus detailed information related to the business. And then fact table means you'll have all the reference keys, all the dimension keys will be there in the fact table, and then you'll have measure information. Now, schema means collection of these dimension tables and fact tables. Right? So why? Because when you go to the practical thing in project, by seeing the tables, you should be able to find out, oh, this is dimension table, oh, this is the fact table. Because based upon this behavior, based upon this nature, what kind of information is there in the table, based on that, we can decide there and make a relationship of our own. So, schema types, like what types of schemas? Star schema, snowflake schema, galaxy or integrated schema. Star schema, galaxy or integrated. Star schema means like centrally located fact table surrounding by dimension table. Centrally located fact table surrounding by dimension tables. These all is a dimension tables. Okay, these are the dimension tables. And the snowflake schema looks like star schema only, but you'll have extension relationships like this. Okay, you'll have extension of dimensions. Whereas galaxy, it is having it's a combination of star schema and snowflake schema, and it have multiple fact tables and multiple dimension tables. This one, 2, 3, 3 fact tables, and multiple. But a star schema and snowflake schema, both schemas, fact table is one only. Fact table is one only. You'll have multiple dimension tables. But whereas galaxy, fact table itself is multiple, dimensions also is a multiple. Okay. Then we also discussed about the types of dimension tables. There is a 5 types of dimension tables. How we got a 3 types of schemas based upon the nature, based upon the purpose, based upon the connectivity of the tables. We got different names: star, snow, integrated. Similarly, here also types of dimension table means based upon the data. in the table, based upon the data in the dimension table, we call it as 1. Based upon the role it is playing in the schema, we got one type of dimension, and based upon the usage of the table, we got one. You see, first one is confound dimension. Confound dimension means within a single dimension, joining or connecting with multiple fact tables. It's called as a confound dimension. A junk dimension means very randomly or rarely used dimension called junk dimension, and it is having low cardinality flag values like active, inactive, male, female, yes or no, true, false. So like that. So that is called as a junk. That is by seeing the data, we decided that is a junk. Confound dimension, based upon the behavior of the relation, we call it as a confound dimension. Role playing dimension is like usage. This single dimension used for multi-purpose, multiple business purpose. I mean, like sales reporting also, date will be used, finance, orders, etc. Like that. Okay.
So here is the date dimension, role playing dimension, basically sales reporting. Okay, those are the titles of the tables, right?
No, it's not business area. It's a business area. Sales reporting also, date is important. Let's assume this is the data mart. Let's say this is the data mart. DM.
Okay, date dimension itself will be a table that is referenced across different fact tables.
Yes, different. You can say different fact tables, or you can say different business purpose. I mean, different business.
Different fact tables, sales reporting and all different fact tables here.
Yes, yes.
Okay, but because here you mentioned something like centrally located. How that is? How can we visualize that from data storage point of view? Like, is there
data storage point of data storage point of view? We don't visualize. There is like looks like tables and schema. You can't see at a DB level, but picture, generally graphical point of view, this is the picture of that, and we can see same picture. I can show you the same picture practically in our Cognos.
Okay.
Practically, definition also same wherever in a database also or other places also. But when you really make the relationships, you get this kind of picture in the reporting. I'll show you that. Even snowflake picture, galaxy picture, star picture, I'll show you practically.
And thing is, the number of entries in a given dimension table, also there is no fixed format, right? There can be any number of entries depending on the business.
Yes, yes. That is also, I'll tell you, ETL people have some settings. That's what is a SCD is there, no? SCD dimension. While loading the ETL people, they will follow some methods of techniques. If they follow type 1, we'll have only current data. If they follow type 2, they'll have entire history. Type 3, only last 2 records like that. I'll show you the job on the table, how it loaded.
Okay.
What kind of data.
Okay.
Okay. Tomorrow we'll do data variation concepts, and then I will also introduce you that framework manager concept, and terminology will change again. Database will have one terminology. Data warehousing will have slightly same, but different naming conventions you might hearing now, right? And when you move to the Cognos, similarly there will be slightly name changes. Okay, in database we call it as a table only. Now here what happened? Dimension table and fact table. It categorizes 2 parts, right? When it comes to the Cognos point of reporting side, it became a query subjects, like that. You'll see that. You'll, as we start practically, you'll get to know. Tomorrow we'll discuss about the schema, this data variation concept, and close out the concepts and move to the reporting. Once we move to the Cognos side, admin and development and support, everything will be practical. I'll explain.
Okay.
This is to understand that funda, what will be there in the inside. So once we go and start using practically, it will be easy and you'll get used to by this time we start.
Sure.
Okay. So if you don't have any questions, we'll stop here then. Continue tomorrow.
Sure.